Hello everyone, welcome back to my channel. First of all, I'm really very sorry. I don't know why the things were not happening the way I wanted it to be. I tried to shoot the video 2 or 3 times, but I don't know why. Sometimes it doesn't work very well. So I thought that I will start the shoot the video to means 13th with a new day. Okay, so first of all, I'll be wishing you all a very happy Baisakhi as well as happy Navratri and all the festivals that are was celebrated all across India with different names. Now let's get started. Now from today we are going to start the general concept. We're going to start the general concepts of organic chemistry. First of all, we should go through these general concepts of organic chemistry because we need to revisit or revise our concepts before starting the main organic portion of the chemistry mains paper. Okay, so a few questions arises in our mind before starting our mains preparation. The first most important question is why there is a need to study chemical reactions. Okay, why do chemical reaction occurs and why there is a need that we should study a chemical reaction. This phenomena of occurrence of chemical reactions can be easily described by the thermodynamics. Okay, we already have studied in physical chemistry portion that everything in universe it tends to attain stability by losing energy. We already know that. Now the question arises, how do the reaction occurs or why does the reaction occurs? The driving force for a reaction to occur is the it is the energy distribution. What do I mean by energy distribution? That the reactions occur so that the reactants lose their extra amount of energy and form products which are more stable by losing the extra amount of energy and becoming more stable. Now the next question arises that we read that the reaction occurs because the initial reactants tend to lose the extra amount of energy and attain greater stability, that is the products which have a lower energy. But the next question arises, how does a reaction occur? Now before starting that how does a reaction occur, one must know that whenever a reaction occurs a new product is formed, and how a product is different from that of reactant, it depends upon the various bonds which were already present in the reactant and the new bonds which were formed after the reaction has occurred. So how does a reaction occur? It occurs via bond breaking and bond formation. New bonds are formed in the reactants which lead to the formation of products, whereas the old existing bonds in the reactants are cleaved so that new bonds are formed. Let us assume an example. Suppose we have a reaction ammonia, it reacts with alkyl halide. Okay, we know that this reaction occurs via these lone pairs of ammonia, these react on the carbon of the alkyl halide, thereby losing of the iodine, and the product formed is NH3 positive CH3. Now see here, the old bond between the carbon and the iodine is broken, whereas a new bond between carbon and nitrogen is formed. Thus from here we conclude that whenever a reaction occurs, in most of the cases bond breaking takes place in reactants and bond formation takes place to form the new products. I hope this concept is very clear to you. Now a new concept here arises that how these bonds are going to be break and how these bonds of new bonds are going to be formed. This concept needs to be understood very carefully. Whenever I say a chemical reaction occurs, by occurrence of chemical reaction means there is the movement of electrons. The electrons are moving from one side to another side basically. Now how we know that the electrons are moving? As discussed in the previous example, that ammonia's lone pair are attacking on the carbon of alkyl halide. Why wait, let me draw. This is ammonia, this is alkyl halide. Why the reaction is occur in this way? First of all, you should know that this CH3I compound, that is the alkyl halide. In this compound, this carbon is electron deficient. Why electron deficient? Whenever a bond is formed between two atoms which have a electronegativity difference, I am denoting electronegativity with this symbol. Okay, whenever a bond is formed between two atoms having electronegativity difference, there is a tendency of distribution of electrons will not be uniform between the bonds. Suppose if there is a bond between two atoms of hydrogen like HH, here the electron will be equally distributed between the two atoms. However, in case when there is electronegativity difference, suppose like HCl, wait, like HCl, like in HCl, you know, the chlorine is electronegative, whereas the electronegativity of hydrogen is very less. So the electrons in this bond of HCl lie more toward the chlorine atom. Okay, now the move, due to this, the electrons are always moving from an electron rich side to an electron deficient side mostly. Now in the example, ammonia and alkyl halide, this carbon was electron deficient, that is, it has a delta positive charge over it, whereas nitrogen has lone pair. So that why the attack was taking place by this mechanism. This nitrogen is electron rich, this carbon is electron deficient. Now here we need to discuss that how we will come to know that this site is electron rich, this site is going to be electron deficient. First of all, keep this thing in mind that a chemical reaction involves the movement of electrons. The whole reaction mechanism depends upon the electron movement, how the electron is moving from one side to another side. Okay, now the concept of how these electrons are going to move, how will you move the decide that the electrons are moving from nitrogen to carbon? Why didn't you say that the electrons can move from the iodine too has lone pair na? In this example, iodine too had the lone pair, we could have drawn it like this, but this is not the case. How we predict that the lone pair of nitrogen are going to attack on this way? This is going to be explained in this question, okay. Now here the concept of Homo and Lumo arises. What do you mean by Homo is the highest occupied molecular orbital and Lumo is the lowest unoccupied molecular orbital. But before that, one must know the concept of molecular orbital theory. Sorry, here it would be MOT. Now what is a molecular orbital theory? We need to understand that. Let's get started with the molecular orbital theory. First of all, what is a molecular orbital theory? Why we have concised a theory? Molecular orbital theory, it explains that when atoms combine together to form molecules, they do so in a particular way. As per this concept, the atomic orbitals are combining together to form new set of orbitals known as the molecular orbitals. Okay, now when the atomic orbitals combine to form the molecular orbitals can be classified into three types. First is bonding molecular orbital, non-bonding and anti-bonding molecular orbital. Why I have written it in this way? Wait, see, suppose these are the atomic orbitals of a element, any element. When these atomic orbitals combine, they form molecular orbitals like this. Okay, now this molecular orbital which has energy lower than that of the constituent atomic orbitals, it is referred to as the bonding molecular orbital. And this atomic orbital which has energy higher than that of the atomic orbitals, it will be called as the anti-bonding molecular orbital. And suppose if there was a atomic orbital here at the same position, molecular orbital at the same position as that of the atomic orbitals, that would be called as the non-bonding molecular orbital. I hope this concept is clear. Now why we need to read, let me explain it with an example. Let us consider an example of H2 molecule. See, in H2 molecule, the electronic configuration is 1s1. So one electron is present in the 1s orbital of one hydrogen atom, another electron is present in the 1s orbital of second hydrogen atom. When these hydrogen atoms combine to form hydrogen molecule, H2 molecule, these atomic orbitals combine together to form a set of new atomic orbitals. Okay, these are bonding which have lower energy, these are anti-bonding which have higher energy in comparison to the atomic orbital. So this is the molecular orbital diagram of hydrogen molecule. One more important thing that must be carefully observed is that in case of H2 molecule, we know that the corresponding atoms both are same, HH. So I have drawn the energy of both the atomic orbitals at same level. However, in case of, let's suppose another case of like HF molecule, we will consider HF molecule. One concept is here that the greater the electronegativity, lower will be the energy of atom. Now how we will explain it? Suppose this is the atomic orbital of hydrogen, it has energy higher than that of the HF, okay. Its molecular orbital diagram will be like this, that is the bonding molecular orbital will be much closer to the fluorine atomic orbital, whereas the anti-bonding molecular orbital will be closer to the hydrogen atomic orbital. These concepts we are going to read in inorganic chemical bonding. You must have gone through the syllabus of the paper 1. It is particularly mentioned that you have to read certain molecules as per the molecular orbital theory. Okay, now why we are reading this molecular orbital diagram? From here I will be explaining the concept of Homo and Lumo. See, wait, now I told you Homo is the molecular orbital that is highest occupied molecular orbital. In case of H2 molecule, the last electron is entering in this bonding molecular orbital, so it will act as a HOMO. Okay. However, this atomic orbital, it is empty, so it is the lowest unoccupied molecular orbital. When we study Homo and Lumo, that we study in reference to different reactants, not a same molecule. When a reaction is occurring, that will involve two reactants now. So we will be observing two reactants and comparing their Homo and Lumo, and then we will decide the electrons will be transferring from Homo of whom to Lumo of whom. Okay, let us continue further. Wait, see, I have clearly explained here that the Homo has a higher energy and it has a donor ability, whereas the Lumo, it will have lower energy and acceptor ability. And one thing must be kept in mind, that the electrons always move from Homo to Lumo. I will be explaining this with an example in next few slides. See now this example. How will you describe that which will be the Lumo and which will be the Homo? For that, one must know one general reference that must be kept in mind is the atomic orbitals when they form a bond. This is the order of energy. This is sigma, this is pi, this is non-bonding, this is pi star, and this is sigma star. As we move upward, energy increases. One must know this is the order of the orbitals when a bond is formed. So we will see that the sigma has lowest energy, so its tendency to donate is the least. Pi has a higher energy in comparison to sigma, but it will have a greater tendency to donate in comparison to sigma. So now I will be explaining how this concept of Homo and Lumo will help us to see how the reaction occurs, how the attack occurs. See, let us consider this example of carbocation, how this concept of Homo and Lumo will be applicable. See, this CH3, it is a carbocation and this is OH negative. This is a nucleophile. I have told you that whenever there are non-bonding electrons, their energy is higher in comparison to pi and sigma. So they will have a more donor ability or tendency to donate. So this OH negative will, these non-bonding orbital will act as a HOMO, that is it will donate. Now in case of CH3 uh, in case of CH3 positive, here how will we see that the which orbital will act as the LUMO? See here, I have drawn the ground state of the hybridization, then excited state hybridization. Here one electron of a carbon is lost because here it is C positive. Now this vacant p orbital, this will act as a LUMO and this OH negative will attack on this carbon, and this way the reaction occurs. Okay, in a similar way we can explain the case of ammonia. See, in ammonia too, there are non-bonding pair, that is the lone pair. They will act as a HOMO. Now same is the case there, that CH3I. This iodine leaves with electrons and forms CH3 carbocation. This ammonia will attack this way and the reaction occurs. So this carbon's empty p orbital will act as a LUMO. Okay, now next thing is, when I referred that the reaction occurs, how will you decide that why we cleaved the carbon iodine bond? Why didn't we cleave the carbon hydrogen bond in this reaction? We know that I told you this reaction occurred like this, non pair, this carbon and this. Why we have cleaved this iodine bond? Why didn't the reaction proceed? Let me change the color. Why did the reaction doesn't proceed like this, attacked here, and this hydrogen bond? This is decided on the basis of the molecular orbital diagrams which I told you, or I described you, yes, previously. See, in case of carbon iodine bond, here the electronegativity difference as well as the size difference between the Ci bond is large. As a result, bond overlap is not proper. So this carbon iodine bond is weak, and also the energy difference between the HOMO and LUMO of the carbon iodine bond is small. So the attack can occur on this. However, in case of carbon hydrogen bond, the carbon and hydrogen का size जो है वो comparable होता है. As a result, when carbon hydrogen bond is formed, the overlap is proper. Due to this reason, the bond between carbon and hydrogen is strong, and the energy difference between the HOMO and the LUMO, that is the HOMO and this is the LUMO, is very large, and the electron cannot jump easily from HOMO to LUMO. That is why this carbon iodine bond cleaves, whereas the carbon hydrogen bond remain intact when the reaction occurs. Okay, I hope this was clear. I will be giving you some questions as well, where you need to tell me which will be the HOMO and which will act as the LUMO. I hope this video was helpful for all of you. Do like, share, subscribe and post your queries in the comment down section so that I better understand what are the issues you people are all facing. Thank you. Have a nice day.